Example 3. A farmer collected the data, table on the right, which shows crop yield, which is Y, for various amounts of fertilizer that's used, which is X. In this case, students, it's already telling us which one is the independent and which one is the dependent, okay? So it says here crop yield is Y, so that's dependent, and amount of fertilizer, which is X, that's independent. Normally on an application, it doesn't really tell you which one is X and which one's Y. So make sure you understand, okay, well, dependent, okay, dependent means Y, okay? And independent means X. So when you're reading a question and it doesn't assign X and Y, then you have to figure it out yourself. Part A, use your graphing calculator or decimals to draw a scatter diagram. Sketch it and comment on the type of relation that may exist between the two variables. So you guys have the plot. This is neither X or Y, okay? That's just extra information that we don't really need to solve a question here. I'm going to use decimals. You can also use your graphing calculator and enter in your data. So here I'm going to flip my computer and pull up decimals. So let's enter in the data. I'm going to pull the screen over a little bit so I can see the data. Okay, so what I want you to do is hit plus sign, go to the table, enter in your X, which is in this particular question is the amount of fertilizer. Okay, so 0, 0, and so on and so on. And 5, and 5. And then once you're done with the X's, go on to the Y. 4, 6, 10, and keep on doing that. Since I don't want to be wasting your time, I've already entered this in. So next task is I'm going to have it all enter in for us, okay? Okay, so here's all of the data. Now what I want you to do next is to type in and then it says here, okay, well, here's all the data. Another thing is you want to look at your scaling. Since X is the amount of fertilizer, we technically don't have negative amount of fertilizer. So normally I make it -1, a little bit on the left side of 0 so you can see the whole thing. In this case, I'm using -10 to 100. Now, Y is the amount of crops yield, also not negative. So in this particular case, as you can see, I'm using -1, but if you want to, you can go -10. Now, if you look at the table, the largest bushels yield is 22. So as you can see, I kind of make this 25. Technically, can you go 30? Sure. 50? Why not? It doesn't really matter, right? You want to be a little bit more than what the data gives you so you can see the screen. So now that we have the graph, I want you to write it in. Okay, let's move my screen back here. Whoops. Gotta move my screen back and then fill in the information. All right, there you go. Comment on the type of relation that may exist between the two variables. So by looking at your graph, it looks like a nonlinear, okay? So draw, so the relation between the amount of fertilizer used and crop yield is non-linear. Okay. Now, if you guys want to, now that we have it, you can even say quadratic, right? Because that's sort of the shape that we can see right here. So we can even go back and put in parentheses, quadratic. All right. Use your graphing calculator or decimal to find the quadratic function of best fit. Okay, so now I'm going to teach you how to use it on your decimal, and which I have to flip my computer again. Make sure you double check all the information is correct. So go down here to the next box in decimals and type in Y, and I want you to find this wavy bar right there, just like that. It should be on the left side of your number 1. Okay, so there's a wavy bar. And as you can see, if I type in the quadratic formula, so not formula, I'm sorry, equation, which is ax to the second, ax squared plus bx plus c. Wow, theirs is not working. No equation is shown. So now you have to be careful to go up here. Can you see up here where it says x sub 1 and y sub 1? You gotta look at your table and make sure you enter in the same exact variable as what is shown on your table, okay? So if you see an x2, then you gotta put in x2. So now that we have the quadratic function and curve, we can write it in. I'm going to move this over and write it in our notes. Give me 1 second. So what I'm going to do for us is I'm going to copy down the A value, the B value, and the C value in our notes, just like this, right? In decimals, we type in the Y and then the wavy bracket, which is approximately. And so now, and all of these are from decimals. None of it has to be done by hand. So now I'm going to write y equals. Now when you're writing an equation in your notes or on your homework or your test, you don't write the wavy bracket, you write y equals and then just fill in the A, B, C value. So negative 0.0171212 x squared plus B value is 1.07652 x and C value is 3.89394, okay? And that is a function of best fit. That means when we enter in the data, whatever the calculator gives us or decimals gives us is the function of best fit. Part C, use a function found in Part B to determine the optimal amount, okay? Again, optimal means the best of fertilizer to apply. Do not round until the very end. So we're gonna go back to our decimals and we want to see what the maximum amount is. Optimal means either the best, means it's a max or min. So in this particular case, as you can see, x represents the what? Amount of fertilizer used, and y represents crop yields, right, in bushels. So when x is 31.438, okay, y comes out to be 20.816. So that's what we're going to go back and write. Okay, the optimal amount of fertilizer to apply. So now are you going to use the x value or the y value? Hopefully you said x, right? And let's look at the x one more time to see. X is 31.438. Now, as you know already, this is the amount in pounds, right? So the amount of fertilizer, because our data was giving us in whole numbers. So we're going to stick with whole numbers, so which is about 31, okay? So amount of fertilizer, let's go back to the notes, is about 31 pounds, okay, for 100 feet squared. So that's our unit of measurement. Now, Part D says use a function found in Part B to predict the crop yield when the optimal amount of fertilizer is applied. So that means we're looking for the y value, right? So let's go back and see the y value. Excuse me. The y value when about 31 pounds of fertilizer is used is about 20.816. And again, because the data is giving us whole number, we're going to round that to about 21, okay, bushels. So we're going to go to this one. When the optimal amount, oops, that doesn't look like amount of fertilizer is applied, about 21 bushels is produced or yield. Okay. And part E said sketch the quadratic function to best fit on the same graph as A. Since you can ignore part A because I didn't want you to do a bunch of dots, okay? So for this one, all I want you to do when it says sketch is just look at your decimals or calculator and do a little sketch. Looks like you're starting at 0 and about 4-ish, 3.8. That's what I want you to do. So 1, 2, 3, 4, so 3.8. And then go back to the decimal and where that is 66-ish. Okay, so approximate that, eyeball that for me. And over here, you can write about 66 and go like that. And label your x-axis. So x-axis would be fertilizer. And y-axis would be bushels. Okay, yield. All right.